Okay. Hello. Welcome to this talk, AI in Unity. First off, a bit about me. My name is Emil. I work for Unity. I am also pretty active in the community under the name Angry Ants. I did some extensions to Unity called Path and Behave. And before that, I worked at another game company focusing on AI. This talk, it's sort of supposed to be intro from concept through method and then finally some code examples in Unity. It's meant to kind of demystify the whole topic of AI. Well, maybe not the whole of it, but at least character AI. So knowing Unity is a plus, especially with the examples, but most of the talk will be more about concepts and methods. So let's start off with what AI is. Pretty broad question, but given that I'm focusing on character AI, we should be able to manage this. Diving into the sort of problems that AI deal with. Player interaction. Anytime that you need some sort of dynamic character interacting directly with the player, pretty high focus situation. Gameplay, crucial moments. So like you need some kind of dynamic behavior, but it has to fall right within some specified box in order for gameplay to progress as designed. And finally, NPC interaction, that is non-player character. So that's more like more of an environment simulation where you through the interaction between non-player characters get some vibe. Why couldn't we just make one big AI that rules them all? Imagine a swarm of very clever baddies. For instance, if we say we play a classic storyline campaign, only every character is player controlled, that would probably be a very long game and a bit frustrating. So we need several levels of complexity and level of dynamic behavior. Also, writers and designers, they don't really like dynamic AIs poking holes in their beautifully crafted plans. To stay on their good side, it's also a good idea to restrict the AI some. And of course, cutscenes, they sort of tend to need to drive on a plot. A regular type AI character couldn't really care less about it. And the alternative of a character that talks plot all the time would probably be a tad annoying. So how do we solve this? Well, the most common solution is you throttle your AI. So that is, you maybe have the same characters, but they have various levels of dynamic behavior depending on their situation. So the most dynamic one is you would want that in a direct player confrontation. So that is usually confined to a certain time and space. You have a versus scenario where you're gunning down some baddies, and you want more dynamic behavior to increase the challenge, and also surprise use of strategy. Like you suddenly find yourself flanked by the enemy character, and yeah, you have a high level of player involvement. So that's usually what makes or breaks a game on its AI side. So it basically takes you from something like this to something like that, if you're not careful. An interesting observation from DICE when they did Bad Company 2. The average opponent lifespan was 9 seconds. So the AI that sort of AI only really had to be interesting for those 9 seconds. After that, it didn't really matter that much. So as long as you have a plan for the next 10 seconds, that should be fine. Yeah, so you should probably sit down and, before you start going on with your amazing big dynamic AI, figure out exactly what are the problems that your character need to solve. Stuff like, for instance, how long does it have to live? What sort of engagement does it have with the player? So that's well worth time spent early in your process. So next level of complexity, allied NPCs. Basically, it goes like this. Player is hero. Even when the player is being a bit of an idiot. Strong allies are great, but you don't really want to feel like the side character to some amazing AI that solves all the problems. So the NPC, the allied AI needs to support the player in whatever he or she decides to do, rather than do the best job ever as a soldier or whatever your game is. So yeah, the brilliant plan that the player apparently has, back that up. And finally, large crowds of characters. This is an area where you can vastly reduce the level of dynamic behavior. Basically, this is stuff like big crowds in a city environment, stuff like that. And some people even subdivide in this level. So that would be based on distance to camera. So when characters are a bit out of view, they don't need to look that smart. So yeah, it's kind of okay if they aren't really the best AIs ever, because people perceive crowds different than they perceive like the direct engagement AI that they meet right on front. So a good way of thinking of it is waves and rings in the water, that kind of thing. So players usually perceive such AI as a moving mass. And as long as the mass in full is convincing and good, there's no need to waste resources, basically, on making it more awesome. And when all else fails, or if you're not sure what you should be doing, you should probably be scripting and animating it. I mean, basically, the most, as it says, most convincing performance is going to be you have some voice actor going and maybe even have him rigged up with motion tracking and all this, so have like a directly scheduled and recorded interaction. So if you can get away with that, you should definitely do it. If you don't need dynamic behavior, or it's directly unwanted or difficult, just try to get away with scripting it, because it's always going to look more awesome. And frankly, if you do a great job, the players won't tell a difference, and they'll find your AI to be absolutely amazing. Which of course it is, because you just spend a lot less resources making a very nice solution. So while this seems something that does directly apply to cutscenes, it's not the only area. So for instance, if you have a big crowd and you have some general sheep AI going on, having the dudes perform okay for some crowd behavior, walking around in a city or something. But then in some area you need you need some specific event to unfold. One way of doing it would be to extend the sheep AI to kind of handle that specific scenario and do it a bit convoluted, but yeah, running it as scripted and animated is definitely preferable. And in case you're picking out already simulated characters and using them, you could, for instance, in the crowd scenario, you could take a circle of characters at a specific location, say whichever character is here, I need them for this scripted animated scene, and repurpose them for that. So that means you can use the same characters with the same dynamic behavior data that's already on there, repurpose them, and then just throttle back up or down in this case to the crowd AI. So you get these seamless transitions. This is a very important one. It's one of the things that's very easy to fall into when doing AI. You want the most awesome, dynamic, real experience, and you then half a year later find out that you've just spent a whole lot of time on something you could have solved with maybe a day or two of animating. So just keep in mind, it's what on the display that's important. It's what sells the game. It's what people will call AI. It's a big difference between game AI and academic AI or other purpose AI. Game AI just needs to look good. It doesn't matter how you did it. So focus energy on making it effective to produce, and then polish as needed on screen. So rapid iteration as per usual in game development. Good idea. Don't start off with some crazy big goal and spend months on it. That's a common response to all this talk about scripting and animating. Feels a bit like cheating. That's great, because this is why cheating is good. You just saved a whole lot of resources and you achieved your goal. You got the awesome behavior on the display and you sold some games and you spent months less, maybe. That's good. And it should be something you strive for, because it not only saves you in the actual production, the initial production of the AI, but the more convoluted and dynamic you try and make your system, it becomes crazy to debug and maintain. So rather start simple, scale up when needed, and animate and script if you can. Another Bad Company 2 example, I know it's 2 in this talk, but they learned some good lessons. I don't know if any of you have played Bad Company 2, but there's a scene where you're driving a convoy of Humvees, and you're being chased by a tank. Now that tank, there's no way it could realistically keep up with the Humvees. But anyway, you have maybe 5 minutes of engagement with it, even though you maintain your speed. So what they do is every time the tank is out of focus, they just move it. They cheat. And the result is amazing, but absolutely unrealistic, unless the American Army has created something new I didn't hear about. But yeah, it's a great scene, absolutely cheating, but very effective and very cheap. The movie industry has another term for it, special effects. If you don't like the word cheating, use that one. But yeah, it works, it's effective, and it's nice. So yeah, that was a small intro to generally what character AI does and is. So how do we make this stuff work? Well, first off, basically many systems in game development use parallel world representations. So you don't have one data set that defines your whole world, you have a collection of them. So, for instance, the rendered one, the one you see on the screen, pretty useful, at least if you have a visual game. Physical, used most of the time when you have characters involved. Game logic, and that's stuff like identifying game objects by components, using layers and tags and all this stuff. And then finally, AI. And now, please excuse me while I grossly oversimplify how that data is used. So rendering uses transformation and combination of the given data. Physics uses monitoring and mutation. Yeah, it was hard to come up with a one-line thing for that. But game logic, generally that's flow management, because you kind of have a defined flow of your game already. You just need to figure out when to use what. So, and AI is a combination of that flow management and search. You could argue that, in some sense, flow management is search as well, because you're finding items and yeah. But yeah, so monitoring / searching, whatever, is expensive because unlike graphics, you don't have you have a lot of unknowns. Whereas, well, I mean, if you didn't have that number of unknowns, it's called an animation, and people are good at that. But since we have player input, we kind of need to deal with those, unfortunately. So what we can do to combat this problem, reduce the size of the data sets. If you don't, like, if there's an area of the game where the player doesn't go very often, no need to mark it up. Billboard the hell out of it, that sort of thing, and increase the quality of each data item that you use to mark up your world. So generally, say more with less words. And to illustrate that, in physics, which I guess a lot of you are familiar with, you specifically mark which objects should be simulated. You provide a simplified geometrical representation of the world rather than using the rendered one. And similarly, to do the same in AI, you simplify navigation and discovery to a search of tree-structured data, which is a simple enough problem. And each node in that tree holds as much relevant final/baked data as possible. A well-designed setup, yeah. Work together between AI and physics as much as possible. Reuse the setup. It's not only a runtime performance improvement.